All right. One other uh, graphical device is what we call a box plot. And what a box plot is, here's an example of one. What a box plot is a way of summarizing. It's a way of summarizing the information we have about the distribution of our variable. Remember, we're after the distribution. We're trying to get an idea of the distribution. And the box plot is a summary. So with summary, we lose some information, but we hope we're going to gain some information by summarizing. So it's a summary, let's say, of what's in the histogram or what's in the frequency polygon, what's in the distribution. And here is an example of one. Now, a box plot is, as the name implies, is a box like this. So there's our box, and the box is placed where? Well, the bottom of the box is placed with this axis here, of course. The bottom of the box is placed so that 25% of the data lies below the bottom of the box. The middle line in the box is the middle of the data, so it's where 50% of the data lies. So 50% of the data, well, if 50% lies below, 50% is also going to lie above. So 50% of the data is at that line. We'll find out later that we're going to call this the median. And then the top of the box is where 75% of the data. So 75% of the data lie beneath the box. Okay, so this is sometimes called the first quartile. The second quartile is also called the median, and then the third quartile is up at the top there. And this distance here between the top and the bottom is called the interquartile range. Then what we do is we go out something like 1.5. There's some debate in the literature how these lines out here should be drawn, but I refer you to the manual, the Stata manual, and they'll tell you how those are drawn. And this is where I got this plot from Stata, so that'll tell you exactly how those are drawn. But what those are drawn out to try and get, something like 90-some% of the data, 98% of the data or so. And then everything outside of that, they called outliers. They lie outside these lines. Now, don't forget that we're basing this on something like 4,400 observations. So there should be quite a few out there, and there aren't that many out there. Now, the thing you want to look at is to see whether, in terms of symmetry, we're always looking for symmetry, is to see whether this distance here is roughly the same as that distance, whether this line, whether the median is equidistant. Is this equidistant from each edge, from the first quartile and the third quartile? That's what you would expect with symmetric data. You would expect that line to be halfway between the edges. So here is a summary, and it's a wonderful little summary because it gives you an idea of what's going on. And what we can do is we can put these things side by side. So for example, going back to our blood glucose level, here is the box plot for those who do not have diabetes, so non-diabetic. And here we have for the diabetic. What we see for the non-diabetics is very tight. The interquartile range is very, very small. So it's very, very tight. And non-diabetics, as far as the blood glucose level and blood glucose control is concerned, is very, very tight. They've got much better control of the blood glucose level than do diabetics, because, and look at the diabetics here, there's a tremendous interquartile range. Also, this line here, the median, is pretty much halfway between in the box there, whereas the distance here above the median is not the same as the distance below the median. So we think we see plus, actually plus. We've got this distance here is much bigger than this distance here. So we're sort of seeing a long tail in this direction. And that's up. Up means higher values, so we've got a long right tail. If we put this on its side, we would have a long right tail. So we can get a lot of information just from this these 5-number summaries. We have a little bit of a contradiction here, is that we have too many of those. No, we don't have equal numbers of those. Possibly these people pre-diabetic and they haven't quite been diagnosed as diabetic yet. I don't know. Maybe that's reading too much into the data. But those are the kinds of hints at the information of what's going on that we might need to pursue. So this is the value of these box plots. Here we go. Here's another one. Here, what I tried to do here is show you. Remember last time we said we looked at the diastolic blood pressure and we said, oh, look, there's a bit of a tail here. There's a right tail. And then we take the logarithm. Well, here's the logarithm. Here's the box plot for the logarithm. And we see now that this is offset by that. This is pretty much the same as that. This is now in the center. The median is in the center. Whereas here it's a little bit below the center. So we see the impact of taking the logarithm of the data, which is what we were hoping to see. And that's why we took the logarithm. Here, now you can put these things side by side. Here, these three are the diastolic blood pressures for the 3 visits. So this would be for visit 1, this would be for visit 2, and this would be for visit 3. And here they are for the systolic. So this is the systolic blood pressure, visit 1, visit 2, visit 3. And it looks like the median is sort of going up here from visit 1 to visit 2 to visit 3. Whereas the systolic went up a little bit, but then at the 3rd visit it sort of goes down. So you can detect these kinds of movements by looking at these distributions side by side, looking at these box plots side by side. Now, be careful, be very careful when you do these kinds of comparisons over time. These are called longitudinal. Be careful when you make a longitudinal. Be careful when you make longitudinal comparisons. Are we comparing the same people? Is it the same people who showed up at the 1st visit as show up in the 2nd visit? And the answer is no. They're not the same people. Is it the same people who then show up at visit 3? No. So possibly, who knows, possibly the fact that this goes down between visit 2 and visit 3 might be related to the people who left the study. Whether they left because they were ill or they passed away or what it was. Who knows? We've got to be careful. For example, what we could do here is redo these plots. Now, this time, I only included those who were measured at all 3 visits. And it looks like we're getting the same message when we include just those at all 3 visits. So just be careful. It's got nothing to do with box plots, but I just wanted to warn you that when you make some comparisons over time, that you are comparing apples to apples. And that's another very important topic that we will be coming to shortly.